Hello all, welcome back to this video on sum of subset problems. Imagine you are given a set of positive integers and a target sum. Okay, a set of positive integers. What is the challenge? Find a subset from the given set where the sum of its element is equal to the target element. So, what is our challenge here? What is our challenge in this case of sum of subsets problem is to find subset from the given set. Find subset from the given set where sum of its elements, is equal to the target. Okay, for example, my target is 10. So what is the subset that can be found from this set? 1, 2, 3 and 5 is the subset that can be found from this set to reach my target of 10. 1 plus 2, 2 and 3 and 5. 2 plus 3 is 5 and 5 plus 5 is equal to 10. So this is the subset from my given set, positive integers set, to find the target is my sum of subsets problem. This is the challenge. So the problem asks, can we find a subset of the given numbers whose sum is exactly equal to the target sum? Okay, goal. What is our goal? Find all subsets or any one subset of the set whose element add up to the target sum. Okay, so either we can find at least one valid subset or all the other valid subsets. For example, in this case, 2 plus 3 plus 5 is equal to 10, and so on. If I have 6, 7, 8, 9, 10, if I can pick only 10, that will give my target. So one element is also fine from this set. Okay, I hope you understand. My target is 10. I can go with 2, 3 and 5, or either I can go directly with the 10th element in this set as a subset. Either one valid set or sum of all the sets. Okay, how to solve the problem? To solve this efficiently, we use technique called backtracking. What are we using? A technique called backtracking. Okay, think of it like exploring a decision tree. Okay, think of it like a decision tree. At each level, you choose whether to include or exclude. Okay, so either we can go with inclusion of the set or we can exclude the set at each step. If the path looks promising, we can continue. So if for example, in this case, 2 plus 3 is proceeding to 2. For example, here in 2 plus 3 is adding up to 5. So it is progressing towards 10. So the path is looking fine. So we will continue. We will include and continue. Include and continue. Okay. But if it's impossible to reach the target from that point, we will backtrack. Okay, if it is impossible, one more case is, if it is impossible to reach the target, impossible to go to target, we will backtrack it or prune it. Prune or backtrack it. Okay. And try a different path. Try a different path. So now we'll look for the steps in the algorithm. I hope it is clear till now. So what are we using in this problem? In this problem of sum of subsets problem, we are using the concept of backtracking, where we think of it as like a decision tree, and we have inclusion or exclusion at each step, and if the process is going fine or the path is going fine, we will include and continue, and if the path is chosen to be impossible or it is shown as impossible, we will backtrack or prune it and will try for another different path. So algorithmic steps. Start with empty subset. We'll take this example only. First we'll start with empty subset. Okay. For each number you have two choices. Choice 1 is included and choice 2 is excluded. After every decision, if the current sum equals to the target, for example, here we have taken two options, like first one is 2, 3 and 5, and our target is 10. If the current sum is equal to the target, in this case 2 plus 3 plus 5 is equal to 10, will record the subset. If it exceeds the target, for example 1, 2, 3 and 5, if we sum this, it will come up to 11. This is greater than 10, that is our target. So if the sum of the subset exceeds the target, we will backtrack and stop exploring. Okay. So it is clearly explained in the algorithmic steps. So we'll start with an empty subset, that is 0, and at each step we have two options to consider the next number and decide either to include it or exclude it. First we'll start with empty subset and 2. Yes, 2 is nearing up to 10, so we'll include it, and next we'll go to 3. Okay, it is nearing up to 10, we'll go to another, we'll include this and we'll go to another choice of 5, or you can go for with 4 and then come back to 1 also. Either of the sets is fine. Okay, so 2 and 3 and 5 we are excluding, and it is equal to the target. So once if the sum of subsets is equal to the target, we'll record the subset as the final solution. Okay, in this case, in the case 2, 1, 2, 3, 5, the sum is exceeding the target, sum of subset is exceeding the target sum, that is 11 is greater than 10. Okay, so in this case we'll discard or backtrack or prune it, and we'll stop exploring, and we'll continue by adding other numbers. Okay, so until when we'll continue this? Till all numbers are considered or the target is reached. Okay, all numbers are considered or target is reached. In this case, if the sum is less than target, we'll continue adding other numbers. Okay, if the sum of subset sum is less than target, we'll keep continuing till we reach the target. Okay, so this is all shown in the pseudo code. So if the current sum is equal to target sum, we will fix the solution as a valid solution. If the current sum is greater than target sum, we'll discard or prune it, and we'll continue adding other numbers. Okay, continue adding other subsets to form the target. Okay. Next, what are the key points or takeaways from this explanation of sum of subsets problem? Backtracking prunes paths that cannot work and saving time. So the concept of backtracking here is help to prune the path or discard the path. Okay, discard the path, which saves a lot of time. Okay, this is the first key takeaway, and you can sort the set beforehand to make pruning more effective. If the subset is given as random 5, 10, 20, 25, 45, 30, etc., we can at the first step we can sort the subset so that we can make use of pruning in the best way. Okay, so before pruning only we will sort the subset if it is given in the random order. Depending on our goal or the target, we can modify it to stop at the first solution or collect all the possible solutions. So in this case 1, 2, 3, 4, 5, etc. If my target is 1, then there is only enough to pick first subset. Okay, depending on my target or the goal, we can modify it to stop at the first solution. In this case, I'll stop at the first solution because my target is reached. Or if my target is 30, then I'll go ahead with all possible solutions. Okay, I hope everything is clear. So finally, the sum of subsets problem is brilliant example of recursive backtracking in action. So how can we treat sum of subsets problem is like, it can be a good example of recursive backtracking in action. Okay, so sum of subsets problem is also named as recursive backtracking in action. Thank you.